Hello ladies and gentlemen, welcome to my humble Android development channel. As you might know, unit testing in Android is more challenging than unit testing in most other Java frameworks. In this video, I'm going to show you why that's the case. Keep in mind that this video was adapted from a section of my new professional Android unit testing course. Therefore, it's alright if you feel like you miss a bit of context. You can find a link to the full course with a special discount code in the description below. Let's start. Android is a platform, an operating system, and a framework at the same time. Only the framework part is relevant in context of this course, however. You can think about Android framework as a superset of Java. In other words, it's Java with addition of special APIs that make Android what it is. This definition is not entirely accurate technically and too simplistic, but it will be useful for our discussion nonetheless. So, you can think about Android as Java with special additions. What you've learned so far covers the part of Android that comes directly from Java. The additional stuff, however, presents unique challenges in respect to unit testing. In this module, you will understand these challenges and learn to overcome or work around them. So, now you know that Android framework can be seen as consisting of two parts, Java part and Android specific part. I would like to start by busting one myth that many Android developers believe. It goes like this: you can't unit test classes that depend on Android specific APIs. To demonstrate you that this is just a myth, I will unit test a class that uses the most horrible of all Android APIs, the monstrous context. So, I'll create a new class in package example 12 located in unit testing in Android module. Call it string retriever. And immediately create the corresponding test class as well. In Android modules, I will be presented with the choice whether put it in Android test or in test directories. Well, Android test is for instrumental tests, therefore unit tests go into test. String retrieval will proxy context object and expose just one single responsibility to the outside world. This responsibility will be, retrieving strings, surprisingly. So I'll create a new test method and call it getString, that will be the method name, and correct parameter passed to context. I would like to assure that when method getString is called, okay, that's the method, and it will have an integer argument, let's say 10, call it ID. According to roll number 2, I need to create this thing right now. Okay, so when this method will be called, I want to ensure that this ID is being passed to the underlying context. To do that, I will need my mock, of course. Nothing really special here, right? Mock of context class, mContext mock. I will need to verify that on context mock, getString method was called and that ID was passed in as an argument. Please note this assertion. Instead of using argument capture, I simply specify that I expect ID to be passed in. Now that you master the argument captors, I feel confident to show you this shortcut. The test compiles, so I can actually run it. Unsurprisingly, it fails, no problem. Go to the production code and let's write some implementation. So first of all, I will need a context class here, right? And I will need to generate constructor. And now to make this test pass, I will need to basically just pass this ID into the context. Let's rerun the test. Yeah, sure. I need to pass into my context. I changed the API of the constructor. Rerun the test. Okay, beautiful. It passes. Next test case. Get string, and I want to assert that correct result returned. No problem. What I'd like to arrange is that when on context this getString called with ID, then it will return basically some string. Cool. So let's extract this into a constant, let's call it string, alright. And now I would like to do the following. String result equals sut get string id. And this won't compile. According to rule number 2, I need to make the return value. And I really want to go and fix the production code now. I want to return this context get string. However, that will be against rule number 3. So I get back to my test and I assert that the result is basically string. Okay, rerun all the tests. Right, this new test failed. Now I can go back and actually fix it. Rerun the test. Both tests pass now. Rule number 1, I need to write more test cases. However, I think that these test cases that I have already cover all the functionality that I wanted from this simple class. What you just saw proves that you can use Android APIs in your classes and still unit test them. However, the widespread myth that you just watched being busted emerged in response to a real problem with Android APIs. It just exaggerates the real problem too much. It's important that you remember that you can use Android APIs and still replace them with test doubles in unit tests. Otherwise, you might leave coverage holes in too many classes. So, what's the problem with Android? Why it makes unit testing difficult? Well, I'll demonstrate it to you by example. Say I want to use isEmptyStatic method from testutils Android class in my classes. This is trivially simple static method that returns true if the string is empty or null. What can go wrong? So I'll create a class, call it Android unit testing problems, and create a new method here, public void, call it, let's say, call static Android API, right? And string. And the only thing I'll do in the body of this method is basically calls testutils is empty and pass in the string. Nothing fancy right here. Alright, create a new test. New test method. Let's call it test static API call. Alright, all I want to do is call this call static Android API, and let's say I pass the empty string in. And even write assert true is true. Obviously this test must pass. Let's run it. It fails. Not only that it fails, it also gives this cryptic error message. Method is empty, not mocked. See blah blah blah. Fortunately, lately it also provides this link to get more information about the error. Let's see what it says. So, method not mocked. The android.jar file that is used to run unit tests does not contain any actual code that is provided by the Android system image on real devices. Instead, all methods throw exception by default. This is to make sure your unit tests only test your code and do not depend on any particular behavior of the Android platform that you have not explicitly mocked, e.g. using Mockito. If that proves problematic, you can add the snippet below to your build.gradle to change this behavior. Some code snippet. We are aware that the default behavior is problematic when using classes like log or testutils, and will evaluate possible solutions in future releases. What this means can be demonstrated if I try to go and see the source code of this isEmpty method. Android Studio decompiles the source from the .jar file, and you can see that all this method does is throwing an exception. In fact, all methods do that. Therefore, any call to Android APIs in tested code will result in exception and test failure. One very important thing you should keep in mind is that you should never set this flag to true. Doing that will indeed allow you to proceed with unit testing if you are using something like static calls, but it will make your test unreliable. For example, if you are using isEmpty method and set this option to true, the method will always return the same value regardless of the input. If you write unit tests against this incorrect behavior, they will fail in real production setting. Therefore, you should never set this flag to true. Forget about it. By the way, notice that even the constructors throw this exception. Therefore, you won't be able to instantiate any Android-related class if you want to unit test. Unfortunately, this restriction applies to data structures as well. As we discussed, from design and unit testing perspective, there is no problem with instantiation of data structures inside the tested classes. However, this doesn't apply if this data structure is Android specific. Let's take bundle for example, which is a special data structure that is used a lot in Android. So I will seek for bundle.class, and Android Studio conveniently decompiles it for me. And as you can see, all its constructors and method are just stubs. These are constructors and these are the methods. It means that you must not instantiate it in the unit tests, and you cannot use its methods. Therefore, even if you simply inject bundle into tested classes, say as a method argument, you will need to mock this data structure. To summarize, if you want to keep a class unit testable, then don't use Android specific APIs. Don't instantiate any Android specific classes, and mock all Android dependencies, including the data structures. If you think about this for a moment, it's not that bad. As we discussed earlier, in general, regardless of whether you develop for Android or any other platform, you should avoid using static methods and you should inject collaborator objects from outside. Therefore, the only real limitation that I see here is on the usage of Android-specific data structures. While it's annoying that you can't use something as simple as bundle, it's really not that bad. So, looks like Android is not that bad in context of unit testing after all. Well, not exactly. Android is horrible in unit testing. The real fundamental problem of unit testing in Android can be demonstrated with this simple activity, myActivity. All it does is incrementing the counter by 1 each time onStart method is called. Now I would like to test this simple functionality. Create a new test and a new test case. Okay, so I want that onStart increments count by 1, right? So sut onStart and then int result equals sut get count. Assert that result is just 1. Absolutely trivial unit test in this case. Let's run it. It fails. And not only that it fails with exactly the same error that you saw in the previous lecture. How is that possible? It's this call to the onStart method of the parent activity that prevents me from unit testing this class. Just like with any other Android API, the methods of activity class are stubbed. Therefore, they throw exception if called in unit tests. The root cause of this problem is in the fact that myActivity inherits from activity class. So even though I wrote less than 10 lines of code in total, this class effectively inherits all activities code. How much code is that anyway? Well, it's not difficult to find out. I'll go to my local copy of AUSP and search for activity.java file. So find frameworks base file called activity.java. Then I'll use clog tool. That's a tool that counts source lines of code on this file that I found. Look at that, 3000 lines of source code and 4000 lines of commands. That's what you get every time you inherit from activity. In fact, you inherit much more than that because activity by itself inherits from a bunch of other classes too. The worst part of it is that there's absolutely nothing you can do in this situation. If you want to write Android applications, you must inherit from activity, and there is no conventional way to replace inherited functionality with test doubles. Therefore, you won't be able to unit test any code that you place in your activities. Just to make it clear, unit testing just part of the methods in your activities is a very bad idea. First, the state of the unit tests will depend on the internal implementation of every single method. Second, if you unit test a class, you must ensure that all its functional requirements are completely covered by tests. Otherwise, unit tests will provide you with a false sense of safety and will allow for bugs in coverage gaps. So, whatever code you write inside your activities, it will not be unit testable. But this limitation is not specific to activity. Code that you write in any class that inherits from Android-specific classes will not be unit testable. Let me list some of them. Application, activity, fragment, view, service, and more. In other words, you can't unit test the most fundamental components of any Android application. This is exactly what makes Android unit testing incredibly hard. In fact, it's simply impossible to achieve full unit testing coverage in Android apps. Joshua Bloch, in his famous book Effective Java, suggested that developers should favor composition over inheritance. Android framework forces you to inherit from its 1,000 slides long classes all over the place. It's a stunning example of what happens when inheritance is abused. Okay, in summary, unit testing in Android is problematic because you can't test application, activity, fragment, service, etc. objects. Now that you know about the issue with inheritance in Android, let's take a step back and try to see the big picture. To do that, it will be useful to imagine that Android application consists of several layers having different functionality. UI layer contains UI logic. This logic is responsible for drawing whatever it is that the screen shows and capturing user input. The next layer is application layer. Logic that resides in this layer is responsible for controlling the application flow. For example, one of the responsibilities of this layer is to process user input and perform navigation between application screens. Then comes domain layer. Logic in this layer is widely referred to as business logic. Business domain and business logic are very fuzzy terms, but there is a good rule of thumb about the logic in domain layer. If it uses names from the real-world business vocabulary, it probably belongs to domain layer. For example, if you are building an e-commerce application, then the logic related to products, cart, and checkout most probably belongs to domain layer. The last layer is infrastructure layer. This layer contains the logic that implements generic functionality like networking, storage, event bus, etc. Now, these are abstract logic layers, and in general, it's not mandatory that each class in the application corresponds to just one layer. However, if you can achieve such a segregation and each class contains logic from exactly one domain, your life will be easier in the long term. Not just in context of unit testing, but also in context of general development and maintenance of the application. At this point, you might expect me to draw arrows between these layers to indicate the dependencies between them. I am not going to do that. Defining the exact interdependencies will turn this abstract notion of layers into a specific implementation. Over the years, developers spent countless hours arguing about the best ways to wire these layers together. I don't want to go there. Treat these layers as an abstract description of logical functionality and don't picture how you'd wire them together in your head. It's irrelevant in our current context. Now, let's discuss the testability requirements of these layers. UI logic consists mainly of Android views which are not unit testable. Therefore, UI layer is not unit testable in general. However, that's not a big limitation because UI logic can be unit tested reliably anyway. Even in frameworks that were designed with unit testability in mind, UI logic still requires extensive manual testing. Just imagine how would you write unit tests that check colors, shapes, and relative positions of UI elements. This kind of verification best left for the human eye. Logic in application layer is mainly responsible for user input handling and flow control. You definitely want to test as much as possible of it. Unfortunately, activities, fragments, and services belong to this layer. There is a widespread misconception that activities and fragments belong to UI layer. However, that's not really the case. The main responsibility of these components is to handle lifecycle events. These events are pure flow control events and are not directly related to pixels on the screen. So, you want to unit test as much as possible in the application layer, but Android's classes get in your way. The best you can do is to keep the amount of logic in activities, fragments, and services to the absolute minimum and extract the rest into unit testable collaborator classes. Domain layer is probably the most important layer to unit test. Fortunately, it's also relatively simple to ensure that this logic is unit testable. Just follow these simple guidelines. Don't put domain logic in classes like activity and fragment. Don't issue static calls from domain logic. Don't instantiate Android data structures inside domain logic. Use cases, which you implemented and tested in the exercises in this course, are very good abstraction for domain logic. Logic in infrastructure layer should also be tested, but sometimes it might be difficult. For example, if I'd use content provider for persistence, I wouldn't be able to unit test it. On the other hand, if I'd use a major ORM library, I could simply assume that it works and just mock it in tests of other units. Let's summarize the testability of the layers. You don't unit test UI layer at all. You try to test as much as possible in the application layer by extracting control logic from Android-related classes. Domain layer can be completely covered with unit tests. Infrastructure layer is largely okay in terms of unit testing. You can also use various libraries and assume that they just work. I remind you once again that it's not mandatory to segregate the application classes according to these abstract layers, but it can prove very beneficial. So, there you have it. Combine the hands-on experience you gained in exercises with understanding of abstract layers of logic in Android, and you have all it takes to tame the Android beast.